Professor in INIA, who I've known Elly for many years because she did a stint in Edinburgh. Elly is going to present one of our invited speeches today, and we welcome her to it, to discuss genetic selection of feed efficiency and methane emissions in sheep and beef in Uruguay, talking about the progress and limitations. Over to you, Elly.
Good afternoon. Buenas tardes a todos. Thank you, Eileen, for your presentation. Yes, we have met for a long time. It's great to be here. It's great to have the opportunity of presenting the work that we have been doing in Uruguay in terms of feed efficiency and methane emissions. Yes. Well, first of all, I would like to give you some background in 2 or 3 relevant points. One is about Uruguay. Uruguay is that small country in South America with 3.4 million Uruguayans, but 12 million cattle and almost 7 million sheep. It's clear that Uruguay is an agricultural country in terms of it's the main economic activity, and both sheep and beef industry are really strategic in terms of land use, employment, and also our current economy, any improvement that our economic situation could have. On the other side, on the other hand, and I was surprised about the comment from the Irish people, in terms of greenhouse gas emissions, our inventory indicates that 75% of the total emissions in Uruguay comes from the agricultural sector. And more than half of those emissions are explained by enteric fermentation, that means methane emissions. So that's the challenge that we have in terms of mitigation strategies. The other point, and has everything to do in terms of this Congress and this presentation in terms of animal breeding in feed efficiency and methane, is the fact that Uruguay has had national genetic evaluations in place for more than 30 years. That means evaluations in terms of beef cattle, dairy, and also in sheep. And since the beginning of genomics and genomics applied to animal breeding, we developed an animal genomic DNA bank between INIA, the National Research Institute, and the Rural Association. And this platform allows us to connect or link DNA samples, phenotypes, or genetic information, genetic data, and the genomic information too. From pedigree animals, from commercial animals coming directly from breeders and stud flocks, selection nucleus, and research projects. And definitely was a great contribution in terms of building the reference populations for genomic selection. And actually the first genomic evaluation that was implemented was Hereford in the context of the Pan American Genetic Evaluation. And last year, the first evaluations, genomic evaluations for Aberdeen Angus and Holstein were in place, and this year for Merino, Australian Merino. Going back in terms of our challenge from the mitigation point of view, it's clear for us that the challenge, the global challenge of, for example, supplying the demand for food and fibers represents a great opportunity for us as a country. But we know that we have to take into consideration not just the environmental sustainability, but also climate change and the commitments that Uruguay assumed in terms of mitigations. In the Paris Agreement, Uruguay agreed to a 32% reduction of emission intensity. That means this ratio between emissions and production. And that was the first step. If from the animal breeding point of view, we were in some way sort of thinking about business as usual, thinking that animal breeding will provide a great contribution in terms of improving production or reducing inefficiency in our production systems, and therefore providing a positive impact in terms of the reduction of emission intensity. But we know now that just improving emission intensity is not enough, and we need actually to reduce the emissions, the methane emissions and the proportion in our inventory. And that's where the new traits, and new traits I'm talking about feed efficiency, residual feed intake, and methane emissions take place within our breeding programs. This new challenge, and for us, we can see this as a problem or as an opportunity. In terms of animal breeding and developing new tools, we decided to take this as an opportunity of improving our production and adding value, thinking mainly that any improvement and growth for us implies supplying to the international market and to the international consumers. And this new challenge find us with many initiatives in place and many work to do. One of these initiatives has to do with the phenotyping platform and the information nucleus. The first work that we started was in Hereford breed, and we started measuring residual feed intake, building the reference population for genomic selection, and in 2017, the first genomics APDs for feed efficiency were published and has been published since then. And if you see in the logo, actually, it represents the meaning of this initiative. And it says, efficiency Hereford, genomics for a sustainable Uruguay. Since 2014, we are running a post-weaning residual feed intake test in Hereford. 3 tests per year. We are evaluated more or less 300 animals per year. And we have a sort of 1 month or 6 weeks of warming up or period. And then we run the feed efficiency test with basically 70 days measurements of daily dry matter intake. We weigh the animals every 2 weeks, so we have the estimation of the average daily gain and the weight of the animals. And we include also in the estimation of residual feed intake the measurement of ultrasound fat measured at the end of the residual feed intake test. 2 points that I wanted to measure here is that the animals that are tested are bulls. There are groups of 3 or 4 animals per breeder, per origin, sire, but at least 2 different bulls within with different of age, though no more than 60 days. And these are all animals that are already included within the genetic evaluation. They must have birth and weaning weight within the evaluation. The other point that I wanted to mention is regarding the feeding, because one of the main questions is, we measure residual feed intakes in these facilities. Production is on grazing. What happens with that? Although it's clear that there's no way that we can simulate or pretend to simulate the grazing behavior of the animals, what we take into consideration is the percentage of fiber in the diet, which maximize the correlation that might have between the trait that we measure in these facilities and the feed efficiency in grazing conditions. And in this test, the post-weaning residual feed intake is measured based on a diet that is 70% silage, usually sorghum silage, and 30% corn grain. So far, we have those numbers of both tested that belong to more or less 70 different breeders that represent 40% of the total breeders within the genetic evaluation. And since then, we have been measuring bulls since the beginning in the post-weaning residual feed intakes, and we have been measuring also steers. These animals were, at the beginning, in the first 3 years, finished on pasture. We measure, again, carcass and meat quality traits. And in the last 3 or 4 years, we do the residual feed intake measurement in the post-weaning and then in feedlot conditions. We again follow all the carcass and meat quality traits of these animals, and since 2020, we started collecting rumen samples and doing methane emissions in both bulls and steers. This information in terms of residual feed intake, we link this information with information in these breeding herds in 2 experimental stations. We selected sires of extreme values for residual feed intakes, and we develop the progeny of these animals, the females, and we evaluate the impact of residual feed intake on the performance of the breeding herds in grazing conditions. And finally, last year, we managed to have the green feed units installed, and so we started measuring methane emissions at the same time that residual feed intake. Something similar, but a little bit different, started in 2019 in sheep. We have facilities that includes, again, automatic recording of individual feed intake and automatic weighting of the animals. This information is part of the evaluation of residual feed intake in sheep, which is complemented with measurements of methane using portable accumulation chambers. The general schemes of this test, again, includes a warm-up period, adaptation period, and then 40 days of measurements to assess residual feed intake. And at the end of the evaluation of the residual feed intake, we do 2 measurements of methane emissions. In this table, you have the number of animals with records. Basically, we are running like between 6 and 7 tests per year, and we are completing this year more than 2,000 animals with all the performance information, the individual intake, and also methane emissions. Basically, all the animals except for the, and this includes 4 different breeds, Merino, Australian Merino, Duni Merino, Corridal, and Texel. And except for Merino Duni, all the animals have been genotyped with 50K or equivalent. And we also have rumen samples that are being sequenced to be analyzed in terms of the association with feed efficiency and methane emissions. Well, what we know in terms of genetics of residual feed intake, well, first of all, the genetic evaluation in Hereford is based on the calculation of the phenotypic residual feed intake using the information recorded during the test, and includes the regression model includes the contemporary group, average daily gain, mid-weight, and ultrasound fat, as I mentioned before. That is something that is different, not necessarily included in all the estimations of residual feed intake. And this is an expression of the variation that we have in terms of the green dots are deficient animals, residual feed negative values for the residual feed intake, and the inefficient ones are the red triangles. Basically, the genetic evaluation was started with a binational reference population that we put together data from Hereford, from Canada and from Uruguay that include phenotypes and genotypes of both countries. And since then, we have been publishing the genomic EPDs. And of course, with the improved accuracy as a result of including the genomic information. Now that we have a database, we can start working on estimation of the genetic parameters. And what we see is that the heredability of residual feed intake is 0.25 with positive correlations in terms of phenotypic and genetic with dry matter intake, what is expected. And basically, the correlation, the genetic and phenotypic correlations with the performance traits are 0 or close to 0. What is positive? Positive in terms that efficiency, high efficiency means lower intake without affecting the performance of the animals. These are the values of the correlations. And we also, based on the phenotype, just at the phenotypic level so far, we started comparing the performance of the animals based on classifications of extreme values for residual feed intakes and seeing what was the trade-off or not with other traits. In terms of carcass quality and meat quality, what we saw is there's no significant trade-off in terms of feed efficiency, what means that efficient steers eat like 20% less dry matter, have 20% less dry matter intake, and the quality in terms of carcass quality and meat quality is the same. When we evaluate the efficiency of the animal in the post-weaning and then later in the feedlot, what we see is the difference in terms of the safe intake is the same, and the animals reach the same final weight with similar level of fatness with less dry matter intake. Similar results is what we found in sheep in Australian Merino. Here, what we have is again the data from the collected in the residual feed intake test in sheep. Dry matter intake, the measure one. Red ones are inefficient, greens are deficient ones. And when we compare the performance of these animals, what we see is, again, residual feed intake or feed efficiency is explained by lower levels of intake, but we haven't found difference in terms of between high and low efficient animals in terms of carcass composition, average daily gain, condition score, fleece weight, and also with FEC. When we compare the performance of these animals that were measured as lambs, and we then compare the performance of the sheep females, in this case as hogget, we didn't see any difference in terms of production traits, and that include fly weights, fleece weight, diameter, and condition score. And we didn't see any difference in terms of reproductive performance either. Methane emissions. Basically, the information that we have so far is in sheep, and is quite relevant in terms of at least start answering some of the key questions in terms of how to implement mitigation strategies. One of the first question is, high efficiency means lower methane emissions? Well, sometimes yes, and sometimes it's not that clear. In this case, the comparison is the same Australian Merino lambs. And we see here the comparison between high, average, and low efficiency. As you can see here, the values are the high efficiency animals eat less, have lower or tend to have lower emissions in terms of absolute values, have lower emissions in terms compared to the average daily gain, but as it was mentioned early in this morning in the session, what we see is that there's a higher value of emissions per unit of dry matter intake. In general, based on the comparison of the Australian Merino and also with other breeds, what we see in general is that efficient lambs measured as with residual feed intake eat between 20 and 25% less and tend to have lower emissions, absolute emissions, but no more than between 5 and 6% less emissions of methane. This is a summary of the table that Gabriel presented earlier, with some of the key traits: residual feed intake, dry matter intake, methane, and fleece weight. The good news, and it's good in terms of residual feed intake too, is that these traits implies that we can improve or we can contribute from animal breeding to increase the efficiency and to reduce the methane emissions. And it's not minor. 5 years ago, we didn't know, we didn't have the data to be sure that we can start working on implementing these strategies. What we see is that residual feed intake is correlated phenotypically and genetically with dry matter intake. And again, it makes sense. And in terms of methane emissions, what we see is that at the phenotypic level, there's no association or there's no significant association between residual feed intake and methane emissions. But we still have a clear association between dry matter intake and methane emissions. And that's the triangle that we need to optimize. Dry matter intake, the association with methane emissions, and the association between dry matter intake and production, and that is feed efficiency. This is data results from in the corridor, as just at the phenotypic level. And again, what we see is lower emissions are associated with lower dry matter intakes, not necessarily associated with more efficient animals. And in this table, what you have is the correlations between the genetic merit of the animals, measured as EPDs for weaning weight, yearling weight, FEC, and fleece weight, and the different traits that we measure in the residual feed intake test. And again, what we see is that higher merit for weaning weight and yearling weight are associated with higher dry matter intake, which are also associated with higher emissions in terms of methane and CO2. In general, what we are seeing now is that low methane emitters animals eat less, but have lighter body weights and lower growth rates. We haven't seen in our data so far clear effects of methane emissions on effect. For example, that is a relevant trait in terms of resilience in the animals, or other performance traits like body composition, which has a lot to do also with carcass composition and meat quality, or with wool production. And we are still analyzing more data in terms of seeing if the association, or clarify the association between feed efficiency and methane emissions. In summary, and it's difficult to summarize something that is really work in progress, but one of the important points for us is that we need to optimize mitigation strategies, and that relies on new phenotypes. It's not business as usual, it implies new phenotypes, particularly if we want to reduce the methane emissions. And we need to get more information for a better understanding of the association among these traits. And if phenotyping is difficult, phenotyping in grazing conditions is clearly very challenging. But again, and it's something that maybe in the last World Congress we couldn't say, is that we know that we can improve feed efficiency and reduce methane emissions by animal breeding. We know that genomic selection is a tool that we can apply and that we can get good responses. And we know, and we have been working on this in terms of international collaborations, not just international collaboration, something more, one step more, sharing data in terms of putting information together to answer our questions. And finally, the challenge now is mitigation of greenhouse gas emissions. For us, it's mitigation of methane emissions. But agriculture and livestock production still provides food and fiber. Take into account not just what is relevant today and is relevant, I'm not saying that it's not, but we have to take into account a comprehensive or a global approach so we can identify and quantify the trade-off. Because at the end of the day, we work in production systems and we need animals that are productive, resilient, and efficient. And of course, now we know that it's not just the genetic of the animals or the host, it's also the microbiota taking place in this. Finally, I want to thank all the partners. I want to thank the opportunity of being part of many international projects that has been really make a difference for us. And of course, all the breeding societies that have supported all this work, and actually they're still supporting the work that we are doing. Many thanks.
Thanks, Elly, for that fascinating talk. We'll ask people in the room to begin to queue up for questions. We have one online, but I also like to invite our wider online audience to get thinking of questions. But if we go to the online one first.
I have a question from Susan. How do you think producers will be rewarded for lowered methane emissions in Uruguay?
I would be a politician if I had the answer for that. No, there are different ways. There are different ways, and actually, Gabriel mentioned one today in terms of the impact in the merino wool, because there are, for example, there are initiatives nowadays that are being implemented in terms of adding value to the wool based on certifications using genetic that support the environment, for example. That's one of the ways that is working, and of course we need to work on developing policies that support these initiatives.
I actually had a follow-up question with my own. How far away do you think we are from Uruguayan farmers being able to select for methane? Do you have a guesstimate on that?
I'm looking. In terms of, for example, sheep, in the case of merino sheep, that we have a nice reference population, it could be possible next season for the next selection of rams.
Julius Zennewer from Australia. Thanks for your nice talk and the good initiatives. And I think international collaboration is very useful indeed in putting data together, mostly probably for estimating correlations between traits, especially reproduction. But in reference to your question as well, so you're setting up a reference population for your populations, but most of the traits are measured probably on research farms. So how do you make sure that your reference population is connected to the breeder farms? Are you using prominent sires from breeders? And have you validated, maybe for other traits, whether your reference population is properly predicting breeding values for the relevant breeding population?
First, in terms of all the animals that we are being testing in terms of beef cattle or in sheep, there are animals that are directly linked with the population, the breeding population. In the case of the sheep, also they are part of selection nucleus, or directly animals coming from consortiums with the breeders. So actually, the actually rams being used are also being tested, or the progeny of those animals are being tested within these facilities. At this stage, and after all these years collecting this data, and also involving the private sector in this initiative, there are clear interest from the breeders in terms of starting doing measurements, particular methane, because the packs would be something that we could be used in the farms, to start doing the measurements in their flocks. So that would be a step further in terms of application of this and expanding the reference population.
I had a related question, and Elly, you'll know that we've been doing the same in the UK as well, and selecting from the population is a bit of a nightmare. How do you control, in your beef example, how do you control to make sure you're getting representative, i.e. almost like a random sample from the population when you're selecting sires from particular breeders and then progeny that they're willing to provide to the test?
We don't select, actually, the breeders. They pay for having their bulls tested every year. Okay. So it's the actual, the procedure is from each generation, we send each of the breeders that would like to send animals to be tested. The breeders select those animals that they want to test in the thing. And then we do sort of quality control in terms that all the animals that actually have data are animals that come from groups that are contemporary groups, so, group of animals of at least with 2 or 3 sires, and also animals that already have data within the genetic evaluation. So that's the way also to be sure of linking what we are measuring with the population.
It might be an idea to validate, like, for routine traits in the broader population, because we had the same when we did in the UK. There's like slightly preferential breeders' preferences coming into what you're testing, which can't be helped. But
yes, well, it's a sort of compromise,
yeah,
no? Because
exactly.
it's something that we have a started period when research funding pay for this evaluation, but also now it's a private public collaboration. So the private sector has also something to say, and it's relevant to take into account their opinions.
Any last minute questions? But Elly, I'm sure you'll look at the chat in case people think of something afterwards. But let's thank Elly in the traditional way.
Thank you.